Alright guys, welcome back. So now we're going to start setting up the pyro simulation for our volcano. So you can see I've threw our ocean surface here in a kind of colored box there. So let's go ahead and start adding pyrosim. So you'll notice right now that our scene scale is just massive. It's like huge, it's really big, and I want to scale the mountain down into kind of more traditional values so we don't have to have a tank that's, with values that are just extraordinary. By scaling things down into a more realistic scale, even though this is a big mountain, then all the settings like disturbance and fuel and all the settings that we're kind of used to working with will kind of be relatively the same. If we kind of kept it at this massive scale, our fuel would be 300 and our buoyancy would be like 1,000% and all this kind of thing. So if you're used to working with the pyro, then at a certain scale, then you can kind of dial in some parameters that you're used to working with, and you can pretty much expect these types of results. Okay, so I'm just going to start a new geometry, and this is going to be, we're going to have to collide with our mountain as well. So let's throw down a geometry, call this mountain collide. And let's see, let's go in here. I want to grab the same file cache here. So let's Control C that. And turn this off, and in the mountain collide, actually I'm going to use an object merge instead of re-importing. Another cache. Let's go into our mountain, which will be terrain mountain, and then find that file cache, and it's our volcano here. So bring in that, and transfer that into this object. So there's a volcano. What I want to do is I want to convert this into a polygon. And then I want to reduce the polygons quite a bit to make it lighter. So there we have it. Let's reduce. Let's throw down a poly reduce. And we reduce the whole thing to about 10%. This will take a little while to cook. All right, so now that we have that reduced, now I'm going to transform it down. Let's transform the whole thing down to 0.1. So we still got a big mountain, but if we just kind of create a sphere and bring up a sphere, this will be 1 meter, and so our emitter will be kind of from here to here. That's going to be, about 5 or 6 meters. So we're scaling down quite a bit, but in doing so, we're able to use turbulence values and everything that's fairly standard without having to blow up these parameters super large. So all right, so we got that transformed. Now for the VDB to calculate correctly for the collider, I want to give this a little thickness. So I'm going to throw down an extrude volume. And by default, we're giving it a depth of -1. And there you go. We've kind of extruded it down, and we're choosing flatten base. So we're giving it some thickness there. And we've reduced it. So that's going to work good for a collision. So let's kind of hold on to that for now. Now as far as the pyro setup, we're going to be using the new sparse solver in Houdini. And we still got all the old methods of emission in that. But the pyro setup has changed a little bit. And we can actually do this in SOPs. We could throw down a pyro solver, and we can build it all from scratch. There's a couple of presets as well, and the fireball, billowy smoke. If we just drop down a pyro solver, you'll notice that things are a little different. Let's go back to frame 1 so we're not cooking. Things are a little different. We've got start frame, all our voxel size, collisions, visualizers, and in the solving, we've got our time scale, velocity, cooling rate, the ambient temperature, which is what's the temperature of the fluid just by default, and then the reference temperature, this is going to directly be linked to the amount of buoyancy that it's going to get. So with a higher reference temperature, we're increasing the buoyancy scale a lot as well. And this is also going to increase the overall shading and heat and that of our fluid. But then we've got the flames, we've got lifespan of how fast the flames are going to burn out. And if you remember the previous pyro, we had a fuel source. So now they've gotten rid of the fuel, and they've kept things a little bit more simpler, and they've just got a flame and a burn rate. And it's a little bit more similar if you've ever worked with fume effects. And then we've got things like smoke. We're emitting smoke off those flames, a range that we can emit in, temperature, expansion, which is really similar to fume effects, expansion of the fluid, and then all of our shape parameters, dissipation, disturbance, shredding, turbulence that you're probably used to seeing. And then the advanced, where we can click on the OpenCL, and where we can choose to use our sparse grid is under the advanced section. We've got our resizing parameters in that, but then we've got the sparsity. So by deselecting sparse solving, we're going to be using the regular solver, and then we could choose to use the OpenCL solver. So this is where you would enable that. So the other method that we're going to use to create this instead of in SOPs is we're going to do it more like the traditional Pyro solver in the previous versions of Houdini, where we're going to use a DOP network up in the geometry level to create our volcano. And I'm going to do that because the setup is just a little bit more similar to the last versions of Houdini, but yet we're going to be using the new sparse solver. So I'm just going to delete this Pyro solver, and let's go up to the object level, and let's use a shelf tool. You'll see we got the pyro effects, and then we've got a sparse pyro effects. Let's start with the sparse fireball. We just click in the viewport to select a location. All right, so this is a bit more traditional. We've got a source. Let's put this up here. We've got a source, a DOP net, and a fireball import. Okay, so if we just dive into the DOP network, it's a bit more traditional Houdini pyro here, and it's built up like you're probably used to seeing. We've got our sparse object now, a sparse solver, and our volumes. And we've also got a place for forces, which is on the right side there, as well as all our advection for more gas solvers and that in there as well. If we throw down the original pyro solver, you'll see we're a little bit different. They've gone away with the pre-solve node. And if we just kind of dive in here, it's really similar to the other node in SOPs, but we've got our simulation parameters. And you'll see by default, the fireball has a reference temperature of 3000 now. And it's all set up for this fireball effect. We've got a longer flame lifespan. We're emitting smoke off there in specific values. They're adding temperature by default and expansion. And we've also got the shape tab and then our advanced. But since we're actually using a smoke object, if we go to advanced, we can see in our sparsity tab we're enabling sparse solving. But also we have to check in the smoked object the sparse solving here. You see how this is key. This is linked to this setting here. So if we deselect that, it's going to automatically deselect in here as well. So again, if we disable this, we're going to have the regular pyro solver, or now we can enable the OpenCL, or we can select that off and then reselect sparse solving. You can see it's enabled it here. We're all ready to go. So by default, the fireball setup is fairly close to what we're going for. One thing I want to do is just work on our source first. So if we go into our source, this is pretty similar to previous versions of Houdini as well. We've got our source here. Let's just take a look. Got our fireball base, which is this sphere. We're scattering points in a volume along it. And then we're adding a bunch of different attributes now. We're adding this burn attribute and then a temperature. And you'll notice we're not adding fuel anymore, and we're also not adding density, but we're going to want to add some density into this. But also, if we just keep going, we've got the noise field that's the same, and then we're rasterizing that. We're adding these specific attributes in there, and that's what the volume source in our pyro setup is going to be sourcing. So we're going to be bringing in those attributes there. All right, so first of all, let's just go to our source and let's place this in our volcano. So let's just kind of bring it up to the mouth of the volcano here. And since I've already found these values, I'm going to just punch those in here. I'm going to make it a little bit thicker. So it's going to be a thickness of 0.7 because I want to add a little bit more of actual volume to be emitting. If it was really thin, we'd get quite a bit less volume to work with. Make it wide. And just kind of bring it up into the center. So we're kind of in the mouth of the volcano there. All right. And if we just kind of go back, we look at our fireball import, and we're pulling in the final render here. We're pulling in our simulation. If we were just kind of press play as it is right now, we get this big fireball that bursts up. It's going to kind of die off fairly quickly, like an explosion. So the next lesson, we're just going to go ahead and start changing the actual source to get something that is going to be constantly emitting like the volcano would be.